This Coast and Climate Hurricane Week special is sponsored by Eva Lagarde Center for Coastal and Environmental Studies.
Hi everyone, meteorologist Steve Caparotta here with this episode of Coast and Climate. It's Hurricane Week and we're trying to get you ready for the hurricane season. But today's episode, we're going to kind of step back in time a little bit and focus more on Hurricane Ida and what happened last year. Really excited to have the guest join us today that we do. It's Dr. Jack Bevin. He's a senior hurricane specialist at the National Hurricane Center. Just a little bit on Dr. Bevin's background. Got his bachelor's degree in physics from, you guessed it, from LSU right here, way back in 1984. Went on and got his master's and PhD from Florida State in meteorology. He's been at the National Hurricane Center for a long time. He's a Baton Rouge native, so that's why I wanted to bring him in today. Not only because he's a Baton Rouge native, but also he was the lead author on the Hurricane Ida report that we're going to kind of dive into today. He's the chairman of the supervisory committee for the Hurricane Tracks Reanalysis Project. I'll let him tell you more about that in just a moment. But he was also the recipient of the first State of Florida Emergency Preparedness Program of the Year Award in 2009. So with that, let me bring in Dr. Bevin now. Dr. Bevin, thank you for joining me today.
My pleasure, Steve. Thanks for having me.
Okay, so before I get into Ida, which is the main thing I want to talk to you about today, since you are a Baton Rouge and Louisiana native and you've been at this for a long time, can you just talk a little bit about when you first got interested in hurricanes and how you got to where you are now at the National Hurricane Center?
My interest in weather, including hurricanes, goes back to elementary school when I was in Baton Rouge, and I've been doing this for a long time. In both elementary school and high school, I was known as Jack the Weatherman, and started my formal education in that led to meteorology at LSU, and I got a physics undergraduate degree there, a bachelor's in physics, and then I went off to Florida State to get my master's and PhD in meteorology. And during my time at Florida State, I started interning at the National Hurricane Center. And after I finished my PhD, I got hired on full time, and that was back in 1993, and I've worked there ever since. I worked my way up through the various ranks and became the one of the hurricane specialists in time for the 1999 hurricane season. So I've been doing this a long time, as you said. My interest in weather goes back way, way back. So.
No, that's coming up on 30 years, I guess, at the National Hurricane Center. So congrats on that coming up. So I brought you in today, as I said, because you were the lead author on the Hurricane Ida report, and obviously that was an historic storm for the state of Louisiana, and really, even when you look on more of a regional scale, and we look at the history books here along the Gulf Coast, just one for the books for sure. Before I get into how strong Ida was, and maybe some people want to know why it wasn't a Category 5, one thing that I thought was real noteworthy about Ida was I thought that overall it was an excellent forecast. How was the forecast from your perspective as somebody that worked the storm and actually at the National Hurricane Center?
Overall, the forecasts on Ida were quite good, particularly the track forecast. From the time that the storm formed, we accurately forecasted it would come into the Gulf of Mexico, probably through western Cuba, and then make landfall somewhere in Louisiana, then recurve and move somewhere through the eastern United States. And the track forecast errors that I put in the report actually are much lower than the average, except at the longer time frame where we had some speed errors after it made landfall. But for the time leading up to landfall, when we had the forecast consistently zeroed in on southeastern Louisiana, those track forecasts were quite good. There were only minor shifts, and the actual landfall area was in the cone. It was actually very close to most of the forecast tracks. The intensity forecasts were generally pretty good for the Louisiana landfall, as is often the case when we have a storm that undergoes rapid intensification. The forecast intensities were a bit too low, but we did say from the very first advisory that the storm would be at or near major hurricane strength as it approached the northern Gulf Coast, and reinforced the chance that a major hurricane would hit the northern Gulf Coast, particularly Louisiana, with every passing advisory. So in that regard, the track and intensity forecasts were quite good. Some of the Genesis forecast, where we've actually forecast the formation of Ida, those were not quite as good. We had some issues with how fast the system came together when it finally did, but we did see that something was going to come. It's just that maybe we over forecasted a little bit. So had too low probabilities, and then once the storm started to come together, they didn't catch up with it. But the track and intensity, particularly for the Louisiana landfall, were quite good.
So one thing you kind of hit on that I remember being discussed at the time, and I don't know if it was a first or just one of the first times that we've seen this, but you mentioned advisory number 1 explicitly forecast that rapid intensification. Can you remember ever doing that before or seeing that in the National Hurricane Center forecast?
We have done that maybe a few times. I don't remember the exact specific example. Over the last 5 or 10 years, as our forecasts of rapid intensification have gotten better, we've gotten bolder with those intensity forecasts. Although Ida, was very rare, we start out as a depression and forecast is going to be major hurricane or at or near that when it makes landfall. So in that regard, it was uncommon. But I can't remember the exact storms. I think we've done that once or twice elsewhere along the way, but Ida was kind of exceptional that we forecast out of the first advisory, and it pretty much came true, pretty expected. We could see from the various conditions along the track of the storm that the various upper atmospheric winds and the water temperatures in the Gulf of Mexico were going to be favorable for rapid intensification. And like I said, we under forecasted a little bit, but we could see it was coming and tried to forecast accordingly.
So you being a Baton Rouge native and talking to you before we start here today, you told me your parents still live here in Baton Rouge. The track forecasts overall were excellent. But here in Baton Rouge, that little bit of a jog as it got near landfall and after landfall off to the east, 20 or 30 miles, made a huge difference for Metro Baton Rouge, didn't it?
It did make a bit of a difference, and there were 2 ways. One, the wind field on the western side was not as large as that on the eastern side. So when the storm made that little northward turn, it basically kept Baton Rouge closer to the western edge of the stronger winds. If you look in the report, you'll see some strong wind gusts in the Baton Rouge area. But it could have been worse if the storm had come a little further west and a little closer to some of those earlier forecasts. The other thing was there was a very sharp gradient in the rainfall on the western side of the storm. The eastern side of East Baton Rouge Parish got several inches of rain, and the parts over near the Mississippi River at the western side got a lot less. And that gradient, that sharp boundary in the rain, was set up right over the Baton Rouge metropolitan area. So if the storm had come a little further west, there would have been a lot more rain to go along with the extra wind.
So being the lead author on that report and just with your connections to Louisiana and doing what you do, I'm sure you've heard some of the controversy. This happens with so many storms, but people always think or often think it was a little bit stronger than what it's been officially classified. So when the official report was released not too long ago and kept the landfall intensity at Category 4, some people were surprised by that. So can you help explain for everyone what goes into determining that final intensity at landfall and some of the challenges that you face?
Okay, this will take a little while. So, first of all, we analyze all the available data that comes in on the storm. It can be from anemometers on the ground, it can be from aircraft data, it can be from Doppler radar. And actually, if you go back and look at Hurricane Michael, where I was also the lead author on the report of that hurricane hit the Florida Panhandle, we had a controversy there whether it was Category 4 or Category 5, and we had to look long and hard to finally determine that it was a 5 instead of a 4. Now, a little comparison between Ida and Michael. If you look at the pressure at landfall, 931 millibars as compared to Michael's 920 millibars, the pressure in Ida was a little higher. Actually, the pressure in Ida was more in line with Category 4. The winds reported by the airplanes as the storm was making landfall, the Air Force and NOAA planes that were out there, were about 10 to 15 miles per hour lower in Ida than they were in Michael. And as a result, that was another data point that leaned more towards Category 4 than Category 5. There were no reliable anemometer reports of sustained winds from the landfall area. The official weather stations in that area did not report anything because they were knocked out by the storm. But that in turn brings us to a couple of these gusts that were reported down at on ships at Port Fourchon. One of them was a wind gust of 172 miles per hour, 150 knots. That particular gust, that is within range of what you would expect with a Category 4. We say that we have a Category 4 of winds of 150 miles per hour. That includes wind gusts up to 185 miles per hour. So that by itself, that one gust by itself is not representative of Category 5. That's just a gust within the expectations for Category 4. The other gust, the 194 knot, 223 miles per hour, if we took that at face value, that itself might justify the upgrade to a Category 5. But we've been unable to find out a lot of the other details about that, particularly how the anemometer was exposed and what kind of anemometer it was, and get the data so we could take a look at it in detail to see just how good and representative that report was. If it's correct, there is a chance Ida might have been a 5, but that particular report is not in good agreement with the rest of the data that was collected with the winds and pressures in the storm. And given that, we don't want to upgrade it to a Category 5 this time. Door is still open. If we can get more data, we can go back and take a look at it at any point. I should point out, I had an experience back in 1997. This wasn't me personally, but this is one that went through the tropical cyclone forecast business. We had a typhoon hit Guam, and an anemometer at the U.S. Air Base on Guam reported a wind gust of 240 miles per hour, which at the time would have been a world record. But the pressures and the damage near the anemometer did not support that kind of wind. Apparently, there were some flimsy structures that were not blown away despite this allegedly very strong wind. And investigation turned out it was instrumentation error. The instrument that was used to measure the wind tended to malfunction in the core of a typhoon. And since that time, we always, when we get one of these extreme wind gusts, we always want to give it a second and third look to make sure we're not getting deked out by something in the data, be it an instrumentation error or something that's unrepresentative of the actual strength of the storm, or some other problem with the reading. But like I said, if we get more information on that 223 mile per hour wind gust, we are open to going in and taking another look at it. Should point out, if you look further down the Ida report, there was a barometer that was in Golden Meadow that reported a pressure about 921 millibars, 0.3 of an inch lower than everybody else. Turned out when that barometer was activated before the storm, it was 0.3 of an inch low to start with. So you can't take that particular measurement at face value, as it turns out. But yeah, I did encounter that and look into that as well as these strong wind reports.
That's a great explanation of what it all goes into, and I hope people get to hear how closely you guys do look at all this and examine it before to decide whether to include it in the report and the official data or not. I don't know if you got to see, I brought up an excerpt from the report where, just so people do realize, I know those wind reports, those gust reports from Port Fourchon got a lot of attention. You did address those in the report, and as you just kind of mentioned, just unable to verify some of that data. And I could show another graphic here. The local National Weather Service, the National Weather Service New Orleans Baton Rouge office did post a picture immediately after the storm showing where that gust to 172 miles per hour was reported on the Seacor Eagle, but data has been a little bit limited. And then we had this tweet from Port Fourchon, the port itself, and it might be a little hard for people to read, but right at the top of that graphic, it claimed a 228 mile per hour gust. But from your perspective, you've got to be able to, A, verify that data and verify that it's good quality data, right?
That's correct. And these days it's a lot easier to do that, and we have more capability to do that kind of verification than we did in the past. And you talked about the reanalysis project. Some of the storms that we've looked at in the past, we have hung our hats on one particular piece of data And the quality of that can sometimes be a little dubious, but in a lot of cases, we have no way of checking. Today, we have much better way of doing what we call quality control on the data, checking and making sure it's good and making sure it's representative of what we see in the storm. I mean, even aircraft measurements can be unrepresentative on occasion. Earlier in Ida, before the system became a hurricane, the airplane flew through what was probably a tornadic circulation in the outer part of the storm and got hurricane force winds out there, but that was not representative of the true strength of the system. So now all these things we have to look at when we're taking it into account. And if you look at the graph of the intensities that we put in the report, you'll see a lot of data points on there that we're looking at to come up with the final intensity. And in Michael, when I did that in 2018, we looked at all that. We also looked very heavily at the Doppler radar winds as the storm was going into the Florida Panhandle. And Michael was one of those borderline cases. If we adjusted the winds 5 miles per hour up, it was a Cat 5. If we left them as they were, it was a Cat 4. And Ida would have to kick the winds up 10 miles per hour or more to get it up in the Cat 5 time frame. And right now, except for those unconfirmed and unverified strong winds at Port Fourchon, we don't have the data to justify making it a 5.
One other what I thought was kind of a fascinating aspect in your report was this graphic and discussion showing that had Ida tracked about 15 miles more eastward, we could have had some levee overtop. We had some levee overtopping as it was, but could have had more levee overtopping on the west bank of New Orleans. Can you talk a little bit about that?
Yeah, the storm surge that you get in a landfalling hurricane is not just dependent on the strength of the storm, it's dependent on the structure of the storm, where the strongest winds are, how big the wind field is. And also depends very heavily on where it makes landfall. And one of the more drastic examples of that in the last couple of decades was Hurricane Ivan as it was heading for the Mobile, Pensacola area. The original forecast track had Ivan going up just west of Mobile Bay, which would have put a very large storm surge up Mobile Bay. And the storm made a slight nudge to the east, came in just east of Mobile Bay, and you actually blew the water out of the bay in the process and not into the bay. So it made a huge difference in the surge there. And you get a similar impact if you move the track just a little bit in southeastern Louisiana. A couple of the protection systems here in southeastern Louisiana that did not overtop because of where Ida made landfall, and the strongest winds and the highest tides were not perfectly placed to overtop those levees. If the storm had gone about a little further to the east, equivalent about a 12-hour forecast error further to the east, a couple of these systems might very well have overtopped due to the surge coming in.
Yeah,
and
so I have the graphic up right now. I know it's a lot for people to look at, but just to explain those sort of hatched areas, as I understand it, A and B, those are two of the areas where we could have seen some levee overtopping if that dashed line track had played out instead of the solid line, which is the actual track. So we're talking in the area, the La Rose to Golden Meadow protection system, and then again on the west bank of the New Orleans hurricane risk reduction system, correct?
That is correct. And you have to understand the difference in those two tracks is about equivalent to the 12-hour forecast error, which means if we're trying to forecast, make this forecast at the time that you have to evacuate these areas, the error bar on that forecast is going to be much bigger than the slight difference between those two tracks. So when we put up a storm surge warning and the accompanying hurricane warnings for an area like southeastern Louisiana, you have to cover a large area, and you can't really micromanage which of these surge protection systems may overflow and which may not on the basis of our current forecast track, because small shifts in that track means that some areas that were in danger might come off a little better, but some that might have been less danger could come off much worse. And that's why you have to sort of put this blanket broad scale approach onto the storm surge warning to the evacuation. that slight difference in the track that made that big difference in the surge is well within our forecast margin of error, particularly at the time that the emergency management officials in Louisiana have to pull the trigger on evacuations.
I don't want to keep you too long, but I do want to get one or two more questions in. So question number one for you. Ida's impact here in Louisiana, I think the last count was 4 direct fatalities and 26 indirect. So the direct ones are the ones that essentially happen during the storm, directly related to the storm, and the indirect are usually in the aftermath. Are we to a point now to where our forecasts are getting so good that we almost need more focus on the aftermath in terms of the safety aspect than the storm itself? It certainly seems to be at least a trend over the last several years.
I would say while the forecasts have gotten better, they are not to the point that we should be focusing more on the impacts on the casualties in the aftermath than during the storm. All it takes is one storm like Katrina, which comes in and inundates even more vulnerable areas that happen in Ida and will run up a massive death toll like we did back in 2005, both in Louisiana and Mississippi. In the case of Ida, the forecasts were good. The warnings worked. For the most part, the surge protection systems did their job. And as a result, we had a rather low death toll from the direct impacts of the storm in both Louisiana and Mississippi. We do, I think, need to play up more the possibility of bad things happening during the post-storm phase. What happens when you have no power for several days to weeks? The hazards of trying to go out and do post-storm cleanup or repairs or things like that. And there probably needs to be more emphasis on that, but not at the expense of the emphasis of the hazards of the storm. If you let up for even a moment thinking that you've got that under control, you're going to get a storm that leaps up and bites you, and you're going to come up with a pretty sizable death toll. So, the forecasts have gotten better. The warning and evacuation process has gotten better. But all it takes is for one breakdown, we'll get a storm that'll be like a Katrina or be like an Audrey in 1957 or a Camille in 1969, where we had a large coastal death toll.
Yeah, we certainly have our share of storms to talk about here in Louisiana, no doubt. All right, one last question. So earlier this week, I was joined by Dr. Phil Klotzbach, who does best known for a seasonal hurricane forecast, but he's also authored a couple of papers recently. He's among a growing chorus of people that think maybe the Saffir-Simpson scale has kind of reached the end of its life cycle, or maybe we need to come up with a better way of classifying the damage potential with hurricanes and storms. He wants to focus more on or thinks we should focus more on the minimum central pressure with the storms. How do you feel about it? I'm still kind of a fan of the Saffir-Simpson scale and its simplicity, but being as long as you've been doing this, how do you feel about the Saffir-Simpson scale and where we stand in 2022?
Well, in 2022, we're not going to make major changes, because changing how we categorize the threat of hurricane damage is going to be a considerable effort. First of all, the scientists have to come to a better consensus of what's important in determining the potential of the hurricane to cause damage. Central pressure could certainly be used as one of those metrics, but a lot of other things could be used as well. For example, Hurricane Harvey, the main damage from that storm was from the heavy rain, and the rain is not correlated to the intensity of the storm at all. And that's one of the places where some of these metrics sometimes fall down, even the Saffir-Simpson hurricane wind scale. So for 2022, we're not going to change very much. For the longer term, we do need to get a better agreement on this. We also need to educate the public. The public, the emergency management community, the media, they are all in tune pretty much with the Saffir-Simpson hurricane wind scale. And it's something simple they can grasp, 1 to 5 scale that highlights the threat. So it's not perfect. And as I said, the rainfalls can sometimes be an issue. Sometimes the winds and the storm surge can get out of sync, as happened in Katrina, which is one of the reasons we took the storm surge out of the Saffir-Simpson scale. But to replace the Saffir-Simpson scale is not just going to be a simple thing. It's going to require an effort all through the field from us as scientists to you as media partners and to the general public to understand the new scale, if we come up with one, and what it means in the way of threats. I mean, the reality is the hurricane damage potential is very complex. There's a wind damage component. There's a storm surge damage component. There is a rainfall damage and flooding damage component, and they differ widely from storm to storm. Hurricane Andrew was a wind event. Katrina was a surge event. Harvey was primarily a rain event, although it was Category 4 wind and surge event at landfall in Texas. But each storm is a little bit different in that regard. That makes it a little bit more difficult to come up with a simple classification, even the Sanford-Simpson scale that covers everything. So that's something we got to discuss before we make any changes here. And once we do, we'll be enlisting people like you to help out with educating everybody with what it means.
Yeah, it's ultimately about focusing on the impacts and kind of singling out each impact, I think, which I think the National Hurricane Center has really done a great job with in recent years. Well, Dr. Jack Bevin, this has been great. I really appreciate your time. And from all of us here in Louisiana, if you can do anything down in Miami to give us a quiet year after a couple of historic seasons, we'd certainly appreciate it.
I think we'd all appreciate that because, Louisiana got affected very badly, and that was just a symbol of how bad those two hurricane seasons were everywhere in the basin. So, we'd like a little more downtime for ourselves than we've had the last 2 years. And here's hoping that things go a little easier in 2022. Keep our fingers crossed on that.
Absolutely, fingers crossed. Thank you again very much. And folks, that'll
welcome.
wrap it up for today's Coast and Climate here in Hurricane Week. We'll be right back same time tomorrow, so be sure to tune in then. And we're into hurricane season now, so now's the time to be prepared and stay alert as we track these systems. Again, we'll be right back here tomorrow.
This Coast and Climate Hurricane Week special is sponsored by Eva Lagarde Center for Coastal and Environmental Studies.